Welcome everyone. This interesting question, given are two blue circles with radius 4 cm and this brown semicircle. All three circles are touching at one common point. The length of this red tangent and this red line segment are equal. Exciting part is, with this limited data, can you find the radius of this brown semicircle? Let's check this interesting solution. Let's assume the radius of this brown semicircle is r centimeter and OC length, this is a centimeter. So basically x is r plus a. Now we know that by theorem, if two circles are touching each other, in this case the blue circle and the brown semicircle, they are touching at point D, then the point of contact and the centers all three lie in a straight line. Now from point now PD, that's the radius of blue circle, that's given as 4 centimeter. OP length, now OP length will be OD, which is radius of brown semicircle, capital R, minus 4. So OP length will be R minus 4. Now from point P, if we'll draw radius PC, we know that radius is perpendicular to the tangent, so this angle will be 90 degree. And PC length is the radius of blue circle, which is 4 centimeter. Now in this right angle triangle, applying Pythagoras theorem, we'll get a square plus 4 square is r minus 4 square. Opening the bracket and simplifying it, we'll get a relation between a and r. Now we need one more triangle to get one more relation between a and r. For that, let's use this second blue circle. Again, these two blue circles are touching at point D. By theorem, their centers and point of contact, they lie in a straight line. Here QD length, that's 4 centimeter. Now from point Q, let's join QG here. QG is the radius and we know radius is perpendicular to the tangent and this radius length is 4 centimeter. Again, with respect to this brown semicircle, let's join this center O with this point of tangency F. And from point Q, let's drop a perpendicular on OF. Now if you look carefully, this figure, that's QHFG, it has got all angles of 90 degree, so it's a rectangle, and in rectangle opposite sides are equal, so your QH length will be x centimeter and FH length, that will be 4 centimeter. How about HO length? Now this full length OF, that's capital R, so HO length will be R minus 4. Now in this pink right angle triangle, applying Pythagoras theorem, where we'll take x as r plus a. So we'll get r plus a whole square plus r minus 4 whole square. That will be equals to, now this length OQ is r plus 4. So hypotenuse is r plus 4 whole square. Now opening the bracket and simplifying it, we'll get another relation between a and r. That's it. We have got two equations, two variables. We'll solve them simultaneously to get value of a and r. So let's put the value of a square here. So we'll get this a square will replace with r square minus 8r. So we'll get this equation here. Simplifying it, factorizing it, we'll get 2r as common. Inside we'll get r minus 12 plus a is 0. Now this equation LHS can be 0 if and only if r minus 12 plus a is 0 or a is 12 minus r. Now again putting this value of a as 12 minus r in this first equation, we'll get 12 minus r whole square is r square minus 8r. Opening the bracket on LHS and simplifying it, r square on both sides will get cancelled down and we'll get 16r is 144. Solving it, we'll get r as 9 centimeter and that's our answer. I hope you enjoyed the solution. I will see you in next video. Till then, tata, bye bye.